So the topic that we have chosen to present on are giant atoms, which are also known as Rydberg polarons. Essentially what giant atoms are is an atom which is stuffed full of smaller atoms inside the electron orbit, which in turn has actually been defined as being a new exotic state of matter.
These giant atoms can be described by this theory called Rydberg atom theory. As you can see from the picture above, this is a sole representation of how these giant atoms can function. In the red represents the nucleus, and the one lone electron orbiting the positive nucleus in black. This image can show you that there's similarities to a hydrogen atom, the positive core nucleus, and the one electron orbiting the positive core is like a hydrogen atom, but there's some differences. These differences between a Rydberg atom and a hydrogen atom is that the Rydberg atom has this one lone electron that will orbit the positive core at a very large distance. This means that it could be 700 nanometers wide, which is 1,000 times the radius of that hydrogen atom. Also, a major difference is that there's no difference in angular momentum states. How these giant atoms were conjured or came up with was a good idea that was proposed by researchers from TU Wien, Rice University, and Harvard. It is said that they started with a Bose-Einstein condensate. This Bose-Einstein condensate is a state of dilute gas of bosons that were cooled to a temperature very close to absolute zero. This in turn will slow the atoms right down, and they will begin to clump together. This team of scientists used a starting point of strontium atoms, and these atoms were cooled down into a Bose-Einstein condensate. Then the team used a laser which energized one of the atoms, and one of its electrons started to lift into a highly excited state. This one excited electron starts to orbit the nucleus at a much larger distance than usual, creating the Rydberg atom. That electron's orbit became so large that the strontium atom started to fit inside that Rydberg atom. That team of scientists observed up to 170 atoms crammed into that one Rydberg atom. But the scientists came up with that the number of atoms inside the Rydberg atom can depend on the Rydberg atom's radius and density of the Bose-Einstein condensate. Also, they found that these atoms do interact, but they're very weak interactions. This is because the Rydberg atom's one lone electron is scattered very slightly by the neutral atoms in its path. Since that one lone electron is very slow, it is not transferred into another state. This team ran computer simulations of the interaction and found that these weak interactions decreased the total energy of the system following a bond between the giant atom and the smaller ones inside it. These giant atoms have some uses, which include discovering weakly bound states of matter, which could ultimately lead to investigating the physics of ultra-cold atoms. Also, they can be probe properties of Bose-Einstein condensates on a very small scale with very high precision. This theory of Rydberg atoms and giant atoms don't have a definitive purpose, but it could be a stepping stone for another discovery in the physics field. Also, it could be deemed a cool property for that only specific atoms can harbor. Ultimately, in turn, this team discovered a neat property that only Rydberg atoms can only harbor. They discovered that they're different from normal atoms because a Rydberg atom has an extended electron orbit in order to engulf atoms that are in the space that the Rydberg atom is occupying. This state of the Rydberg atom was only done by applying this technique called the Bose-Einstein constant, and in turn, they used a laser in order to trigger an electron to an excited state in order for that Rydberg atom to form. In the end, those scientists discovered a neat property only simple atoms can harbor. This neat property can lead to a domino effect in the physics community because this discovery could knock over another idea about atoms and their behavior.